Welcome to MRL. In this learning session, we'll be learning about identities, in particular trigonometric identities. We already know what are identities. We have learnt about algebraic identities. Now here we'll be learning as to what are trigonometric identities and their use and application. Now the identities which involve trigonometric ratios and that are true for any angle involved are called trigonometric identities. The fundamental trigonometric identities are sin square a plus cos square a is equal to 1, 1 plus tan square a is equal to sec square a, and 1 plus cot square a is equal to cosec square a. These identities can be used to prove other trigonometric identities. Now let us prove these three basic identities first. Now in triangle ABC, we have a triangle ABC here, angle B is 90 degrees. By applying Pythagoras theorem, we have AC square is equal to AB square plus BC square. We have got AB square plus BC square is equal to AC square. Now let us divide throughout by AC square. I am dividing AB square by AC square, BC square by AC square, and AC square by AC square. We get AB square, AB upon AC whole raised to square, BC by AC whole raised to square, and AC square by AC square is 1. Now what is AB by AC? AB by AC is cos of angle A, that is cos A square, and BC by AC is sine, and therefore it is sine A square. So therefore cos A square plus sine A square is equal to 1, or sine square A plus cos square A is equal to 1, and that is what is the first fundamental identity which we have proved. Now let us go to the next identity. Now since we know that sine square A plus cos square A is equal to 1, we can divide each one of them by cos square A. So sine square A by cos square A plus cos square A by cos square A plus 1 by cos square A. We know that sine by A sine upon, that is sine A by cos A whole raised to square plus 1 upon cos A whole raised to square. We know that sine A by cos A is tan A, so tan A square plus 1 is equal to sec A whole raised to square, or 1 plus tan square A is equal to sec square A. So that is the second identity, basic fundamental identity which we have proved. Now let us go further. Sin square A plus cos square A is equal to 1. Divide throughout by sin square A. We get sin square A by sin square A, cos square A by sin square A, 1 upon sin square A. Sin square A by sin square A is 1. Cos square A by sin square A will be cos A by sin A whole raised to square, and 1 upon sin A whole raised to square. Now cos A by sin A is cot A. Therefore 1 plus cot A whole raised to square is equal to 1 by sin A is cosec A. It is cosec A whole raised to square, and therefore 1 plus cot square A is equal to cosec square A. So this is how we prove the three fundamental identities in trigonometry, very useful in proving other trigonometric identities and calculations. Now method of proving trigonometric identities. Let us understand the method. Now to prove the trigonometric identities, as you know, any identity has got LHS and RHS. Therefore simplify LHS and show that it is equal to RHS. This is the first method, that is simplify LHS and show that LHS is equal to RHS. Then we have proved the identity. Or simplify the RHS and show that it is equal to LHS. Then we have proved the identity. Or simplify LHS and RHS separately and show that they are equal. So this is how we prove the identities. But to prove them, we can use the basics of trigonometry, we can use the basics of algebra, we can use the known identities of trigonometry and also the identities of algebra to prove the trigonometric identities. Remember that. Now the next important and very simple example I have considered here to understand the example: expressing t ratios in terms of a given ratio. Expressing trigonometric ratios in terms of a given ratio. Let us understand this. Now as an example I have taken here, express t ratios in terms of sin theta. That means every trigonometric ratio has to be expressed in terms of sin theta. Now we are given sin theta, so let sin theta be equal to x. If sin theta is equal to x, then sin theta is BC by AC, and that is x upon 1. Therefore BC is x and AC is 1. By the Pythagoras theorem we can find AB, and AB is equal to square root of 1 minus x square, because AC square is equal to AB square plus B square, and BC square, AB square is equal to AC square minus B square, and that is 1 square minus x square, that is AB is equal to root of 1 minus x square. So now we have all the lengths of all the three sides of the right angle triangle. Now we can go for expressing the other trigonometric ratios in terms of sin theta. Now cos theta is equal to, as we know, cos theta is equal to AB by AC, and AB is, you know, it is 1 root of 1 minus x square, AC is 1, and therefore I can just straight away go for root of 1 minus x square. We know that x is sin theta, and therefore it is square root of 1 minus sin square theta, and therefore cos theta is equal to root of 1 minus sin square theta. That means I have expressed the cos trigonometric ratios in terms of sine. Now let us go for tan, and you know that tan theta is equal to BC by AB, that means x upon root of 1 minus x square. X upon root of 1 minus x square, x is sin theta, x square is 1 minus sin square theta, so we have sin theta by root of 1 minus sin square theta. That means I have expressed tan theta again in terms of sin theta. Now cosec theta, as it you know, it is 1 upon sin theta because reciprocal. Then sec theta is equal to 1 upon cos theta, and we know what is cos theta. The value of cos theta is root of 1 minus sin square theta, therefore I can put it here. So it is 1 divided by root of 1 minus sin square theta, therefore sec theta is expressed in terms of sin theta. Now let us take cot theta. Cot theta is 1 upon tan theta. We already know what is tan theta, that is sin theta divided by root of 1 minus sin square theta. Putting it here, we get root of 1 minus sin square theta divided by sin theta. So this is how we can express one trigonometric ratio. That means we can express all other trigonometric ratios in one particular trigonometric ratio. Here I have expressed all the trigonometric ratios in terms of sin theta. A very important example generally asked. The next important study is expressing a trigonometric ratio in terms of other ratios. This is very interesting. We have to express sin theta in terms of other trigonometric ratios. Let us understand. Now express sin theta in terms of other trigonometric ratios. Let us understand this. Now sin theta is equal to root of 1 minus cos square theta. We already know this. Sin theta is equal to root of 1 minus cos square theta by using the identity sin square theta plus cos square theta is equal to 1. That means I have expressed sin theta in terms of cos theta here. Therefore sin theta is equal to root of 1 minus cos square theta using the identity. Now coming to the next important, sin theta is equal to tan theta divided by root of 1 plus tan theta. That means I am expressing sin in terms of tan. But let us see why it is true. Now we know tan theta is equal to sin theta by cos theta. That is sin theta is equal to tan theta into cos theta, taking the product here. That is tan theta, cos theta is reciprocal of sec, therefore it will be tan theta by sec theta. But we know that by identity 1 plus tan square theta is equal to sec square theta, or sec theta is equal to root of 1 plus tan square theta. Therefore I can replace sec theta by root of 1 plus tan square theta. Therefore sin theta is equal to tan theta divided by root of 1 plus tan square theta, and that is what is the sin theta value here. So sin theta is equal to tan theta divided by 1 plus root of 1 plus tan square theta. So please check here, it is not tan theta, it is tan square theta. Now coming to the next, that is sin theta is equal to reciprocal, as it is 1 by cosec theta. That means I have expressed sin theta in terms of cosec theta. Now sin theta in terms of sec will be sin theta is equal to square root of sec square theta minus 1 divided by sec theta. Now how it is possible? Now sin theta by cos theta is tan theta. So sin theta is equal to tan theta into cos theta. Tan theta, cosec theta, cos theta is the reciprocal of sec, therefore it is tan theta by sec theta. And tan theta is, as you know by identity, 1 plus tan square theta is equal to sec square theta, or tan square theta is equal to sec square theta minus 1. Tan theta is equal to root of sec square theta minus 1. So I can replace tan theta by root of sec square theta minus 1, and therefore sin theta is equal to root of sec square theta minus 1 divided by sec theta. I have expressed sin theta in terms of sec theta. Now to express sin theta in terms of cot theta, sin theta is equal to 1 by root of 1 plus 1 divided by root of 1 plus cot square theta. And how it is possible? Now sin theta is equal to 1 by cosec theta, taking the reciprocal, and 1 plus cot square theta is equal to cosec square theta, that is the fundamental identity, and therefore cosec theta is equal to root of 1 plus cot square theta. So I can replace cosec theta by root of 1 plus cot square theta, and that is how we get sin theta in terms of cot theta. So therefore what we have done here is we have expressed sin theta in terms of tan theta, sin theta in terms of cos theta, sin theta in terms of cosec theta, sin theta in terms of sec theta, and also sin theta in terms of cot theta. We have to understand these basics very clearly, and also why they are true, and this is how we prove. So to get this we have to know this. Okay, remember this. So we use trigonometric basics, then basic identities or fundamental identities to express a given trigonometric ratio in terms of other trigonometric ratios. A very important example taken here. So please try to remember the identities, the fundamental identities. Of course we will be learning how to prove the different trigonometric identities, and that will be a separate learning session because that is the application. So there we will have to practice a lot to prove the trigonometric identities. If you ask me, the more number of trigonometric identities you prove, the more easier it will be for you. So but without knowing the basics we cannot we cannot prove the trigonometric identities. So concentrate more on the learning of basics, then apply them, use them as an application for proving other trigonometric identities or trigonometric examples. So that is what is the basic study of trigonometry for you. Thank you.